Hello all, welcome back again to CET problems on Dev Sir's Mathemagic. Today we continue with some PYQs from derivatives. कल से चालू किया है, आज देखेंगे which shortcuts can be applied. I'm going to take inverse trigonometric derivatives and parametric. Okay, दोनों देखते हैं क्या है. So let us start now straight away with one property or two properties rather. See here, these are two important formulae. First is specially for CET. If gx is the inverse function of fx, if something is given like this, and if f dash x is equal to 1 upon 1 plus x, that is derivative of fx is given, then they ask g dash x, okay, or the other way around. So one function is the inverse of the other, and if the derivative of one function is given like f dash x, then derivative of g dash x formula, how do you remember? Use invertendo for this and replace x by gx. Use invertendo means take the reciprocal and just replace x by gx. So what do you get? Okay, g dash x equal to, use invertendo means 1 plus x goes above, reciprocal करना है, and replace x by gx. That is the answer. That is a formula, one of the formula for inverse trigonometric function. इसका derivative भी है, लेकिन that theory you are not going to waste time in writing all these things. Okay, so this is one more shortcut which I have learned for today, that if gx is the inverse function of fx and if the value of f dash x is given, then how do you find g dash x? इसका reciprocal करो, means 1 plus x goes above, but don't write 1 plus x, replace x by gx. That's the answer. Followed, just replace x by gx and take the reciprocal. Simple to remember. Okay. Second formula is sin inverse x plus cos inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. Just remember these inverse trigonometric formulae which can be used for certain problems of derivatives or integration. Okay, so let's see how these formulae are applied to today's problems. So 2017 PYQ MHT CET. If gx is the inverse function of fx, like this, and if f dash x is equal to 1 upon 1 plus x raised to 4, derivative f dash x means derivative of fx is given, then find g dash x. I have not mentioned the four options here because the answer is only in one step. No need to write all the options. Directly we write the answer. So g dash is the inverse function of fx and derivative of fx is 1 upon 1 plus x raised to 4. Then directly g dash x, derivative of gx. What does the rule say? Take the reciprocal of this, means use invertendo. 1 plus means this goes above, replace x by gx. That's all. But you have raised to 4. Simple, right? Supposing if it was raised to 5, one problem is given for in certain practice sums, model papers, then you will get gx raised to 5. So replace x by gx and take the reciprocal. There is one shortcut formula that you have learned for today. Clear? Finished fast. Shall I go to the next one? Okay. Now this is again inverse function. Y is equal to all this. Find dy by dx. इसके भी 4 ऑप्शन नहीं लिखे because you are going to get one simple answer. Now how do you solve this? Find dy by dx. Don't take the derivative of each term, it will become very complicated. What I will do is rearrange the terms. Okay, rearrange the terms in such a way so that sin inverse 3x and cos inverse 3x are together. देखो अभी क्या करने वाला हूं मैं. अगर ये दो साथ में लिए मैंने, now I'm not writing a board paper, so you imagine certain things. When I take these two together, I can take 6x common. What remains inside? Sine inverse 3x plus 6x has been taken common. Same way, take these two together. 8x common निकालो. Cot inverse 4x plus tan inverse 4x. What is the use of doing that? Simply because I can use sine inverse 3x plus cos inverse 3x is equal to pi by 2. Sine inverse x plus cos inverse x is pi by 2. Sine inverse 10 plus cos inverse 10 is equal to pi by 2. Whatever the value of x in front, if both are same, sine inverse 3x plus cos inverse 3x pi by 2. Cot inverse 4x plus tan inverse 4x is pi by 2. Only thing is x के जगह 4x है, it doesn't matter. So it becomes simpler for me now because 6x into pi by 2. Okay, this pi by 2. 8x into pi by 2. 2 cancel करो. So what remains now? 3 pi x plus 4 pi x. 3 pi x plus 4 pi x कितना है? x को कॉमन अगर निकालो तो 3 pi plus 4 pi is 7 pi. So you get y is equal to 7 pi x. 3 plus 4 is 7. It becomes so simple. Now differentiate with respect to x. dy by dx. Derivative of right hand side. As I explained yesterday, I won't be writing d by dx and all that. Board paper is over now. 7 pi constant outside. D by dx of x. D by dx of x is 1. आसान है ना? Interesting problem. So final answer is dy by dx is 7 pi. That option was given. Followed? So कॉमन निकालने के बाद, कैंसल करने के बाद 3 pi x plus 4 pi x remains because this is pi by 2. 2 गया यहाँ से. 7 pi x. So derivative of 7 pi x is 7 pi. Interesting sum? Okay? So both these were based on certain shortcuts which we can use. Next sum. थोड़ा अलग है. X is equal to a into t minus 1 upon t. Y is equal to a into t plus 1 upon t. Then dy by dx is only this much. 4 options are given. Okay. Now this is based on parametric equations. Okay. Parametric equations means there are two equations of x and y, and there is one third parameter, third variable, either t or theta. So parametric equations हमेशा दो रहते हैं. We know all that. So let us see how to go about it now. Try to recall the parametric formula. Okay. Now basic parametric formula is like this. Find dy by dt, find dx by dt, differentiate x with respect to t, y with respect to t, find dy by dt upon dx by dt, dt gets cancelled, you get the answer as dy by dx. This is a normal method. But if you try to use that method over here, थोड़ा टाइम लगेगा, because dx by dt means a into all this derivative of t minus 1 upon t, similarly dy by dt. So for CET what we are going to do is another shortcut, लेकिन शॉर्टकट यूज करने के बाद थोड़ा एक दो स्टेप है इसमें. सो दैट शॉर्टकट इज t को सेपरेट करो एंड फाइनली एलिमिनेट t. शॉर्टकट मीन्स आई एम गोइंग टू रिमूव t, यानी आसान हो जाएगा. अभी t कैसा रिमूव करना है देखो, x अपॉन e, t minus 1 upon t and y upon a, t plus 1 upon t. Okay, I am trying to isolate this. I am trying to remove. Okay, so as I said, we want to remove t. Okay, isolate t. Isolate करके eliminate t. How do you eliminate t? If you have got t minus 1 upon t and t plus 1 upon t here, it is better to square both sides first. Okay, squaring and adding or squaring and subtracting, that is the method. Okay, now let's see. Now if I square this, you have to square both sides. Squaring this equation, right hand side I will show here itself, bracket squared. Now bracket squared means a minus b bracket squared. A squared minus 2ab plus b squared. T gets cancelled. Squaring second equation. Square of this, a squared plus 2ab, it is a plus b bracket squared. Don't write t squared plus 1 upon t squared. It is a squared plus 2ab, that is 2 into t into 1 upon t plus b squared. T gets cancelled here. Okay, so because of that t getting cancelled, what do we get here? Minus 2 and plus 2. Correct? Now समझ में आया? इसको स्क्वायर किया, इसको स्क्वायर किया, we get two equations, 1 and 2. Now obviously we might think that if we add both the equations, minus 2 plus 2 cancel होता है, something कुछ तो आसान हो जाएगा, लेकिन नहीं. Although minus 2 plus 2 are getting cancelled, what remains is t squared plus t squared, 2t squared हो जाएगा. Our job is to remove t. Our aim is to remove t. So I am not going to add equations 1 and 2. I am going to subtract equation 2 from equation 1. Followed? So subtraction के समय t squared 1 upon t squared cancel हो जाएगा. We have achieved our aim of removing t. So I will say subtracting equation 2 from equation 1. So come on, let's subtract. How do you subtract equations? Left hand side minus left hand side. LHS minus, I am subtracting equation 2 means changing the sign of equation 2. Go to the next term. T squared minus t squared is 0. Minus t squared is 0. इसका भी साइन जो चेंज होएगा because subtracting equation 2. So minus 2 becomes minus 4. That won't get cancelled. minus 2 plus minus 2 becomes 4. This 1 upon t squared minus 1 upon t squared gets cancelled, again 0. So when I am subtracting equation 2 from equation 1, it means change the sign of each term of equation 2. सब जगह पे minus किया. Okay. So what has happened now? You just get a simple equation where t has been eliminated. Eliminating t is one method used for CET so that you avoid differentiating with respect to t 2 times. एक ही बार अभी differentiate with respect to x करना है because parameter t has been removed. Now what to do over here? Multiply each term by a squared. So x squared minus y squared is equal to 4a squared. a squared यहाँ पे चला गया. Now forget about differentiating with respect to t. Just differentiate with respect to x now. Derivative of x squared 2x as usual. अभी t मत करो. Derivative of y squared 2y. Don't forget dy by dx. 4a squared is a constant. Derivative of 4a squared is 0. So you get, keep this on the left hand side, minus 2y dy by dx is equal to minus 2x. Take this on the right hand side. So final step, dy by dx. If you keep dy by dx on the left hand side, you get dy by dx is equal to minus 2x upon minus 2y. Minus 2 gets cancelled. Final answer is just dy by dx is x upon y. Followed? So over here you will observe that this is called elimination of parameter from parametric equations. Now usually this method is used in CETs so that somewhat the speed is increased, right? Otherwise ये थोड़ा और 5 मिनट बढ़ जाता. But now when the problem comes in CET, all these things subtracting 2 from 1 वगैरह mind में सब मन में करना है और do the calculations fast. Just फटाफट cancel करो, get this equation fast. Okay, x squared minus 1 minute. This you get as minus 4a squared. Answer is the same. Derivative of minus 4a squared is 0 and then dy by dx is x upon y. Okay, so all this you have to do in your mind and calculate. Right. So this was another method used for CET. ध्यान में आया ना? माइनस 4a स्क्वायर का डेरिवेटिव भी 0 ही है, 4a स्क्वायर का डेरिवेटिव भी 0 ही है बिकॉज minus 4a squared is a constant. So finally you get the same thing, minus 2y dy by dx is equal to minus 2x. So minus 2x upon minus 2y कर दो, dy by dx is x upon y. Followed? Okay, so these were certain simple shortcuts for today. Tomorrow we'll come up with some other problems. Practice करो, share the sums. Bye.